welcome to the stage.
Thank you, Ikram. I brought some stuff and put it there.
Yes, exactly. So no code is always sounding very interesting. So I'm looking forward to see what you have prepared for us.
Yeah, thank you very much. And thank you for having me, having Heisenware. First of all, thank you for organizing that event. There's a lot of effort, and so far everything works wonderful, and we feel very good here in Wolfertschwenn and Multivac. So also thank you to Multivac. Not sure if everyone remote can see the view that we have here in this awesome location. So it's pretty impressive. All right. So, but enough. Let's see how this works. So let's talk about integrating smart devices or physical things, we would probably call it, in the OI4 without coding. So maybe a little bit upfront. We are new to the OI4 Heisenware, and I will show you a little bit more about Heisenware in a second. And we had great discussions the last 2 or 3 days, and it's we get more and more the full picture of what OI4 means in terms of the community, the network, but also technology. But this is just for us a good way to introduce ourselves to you and then see how we can work together, maybe implement projects together, etc. And let's start. Or maybe 1 or 2 words about myself. Oh, sorry, wrong direction. Now I get it. So I'm head of sales and marketing at Heisenware, and we also have a podcast I will mention in a second. But first of all, the agenda. So I talk about Heisenware very quickly, very briefly, then about the Internet of Things, then about low code in general. We heard about low code already from SophieCode today. However, I will give some more insights on that. Then we combine the 2 things, right? We combine IoT and low coding, and then we're going to see some examples. And hopefully, if everything works well, you see the equipment there, we do a little quick demo of our low code tool later. But yeah, you know, it's live, and let's see if it works out. Okay, Heisenware. I want to try this. It's awesome, right? So it's Heisenware. It was founded in 2021 by Burkhard, who's sitting there. And what we do is we make it easy and affordable and fast for especially SMEs to build custom software, because custom software is something that everyone needs, even though there are those huge platforms. But especially for the smaller companies out there and the medium-sized companies, the Mittelstand, it's something they need, right? And how we do it is with our local platform, the Heisenware App Builder, with our own connectivity engine, VRPC, and a lot of consulting around it, right? Which is always important when it comes to IoT and difficult things. All right, so how did it start? How did the IoT start? It started in 1990 with the so-called Internet Toaster, I think by John Romke. Yeah, I can also have a look there. I don't need to turn around. And in 2030, we will have 30 billion devices connected to the internet. So that's quite a number. And this is why we need fast and easy ways and tools how to connect those devices. And let's quickly talk about use cases. We've seen many use cases the last couple of days here. However, these are some popular ones that we always see. It's remote condition monitoring, it's remote control, right? If this is allowed in a specific environment. There's IoT-based process automation. This is an example here from agriculture in the middle. So, for example, those plants will be watered only if the fertilizer is dry enough, right? So you can save a lot of water, you can save a lot of energy here using IoT technology. And there's another use case which we see quite often. It's fleet management, right? In this case, it's very obvious, those bicycles or the sharing cars in the cities. However, there's always fleets of devices whenever you're a product company and selling a product that you need to manage, that you need to track, that you digitally want to follow. All right, the research. Now let's do a little switch over to the local platforms maybe and the app development. So what the research shows is that there's 500 million digital apps just in 2023, which is the same number as apps from the last 40 years. So there's huge demand. And 82% of the companies say that this custom app development will happen outside of IT, right? And just today, there are already 137,000 IT roles or companies looking for IT people. And these are the roles that they cannot fill because there's obviously not enough talent, not enough software and IT talent to fill those roles. In Germany alone, right? And this is why 70% of app development will be done by low coding and no coding in 2025. What does it mean, low-code platforms? We heard a little bit about it from Sofico before. However, let's give a brief overview. So it's about designing data models, business logic, but also user interfaces without the need to code. You still program somehow, mostly, yeah, because you develop those algorithms. However, you don't necessarily code. There's out-of-the-box widgets and templates and plugins that you can just use and put together. Typically, a low-code platform supports the whole software lifecycle, right, from implementation over maintenance to the end of the lifecycle. And typically, we have cloud deployments when it comes to low-code. However, what we've done, for example, yesterday is putting our low-code platform on the Hilscher gateway using the Flex marketplace in the application management workshop. This is something Burkhard and the others did in the workshop. There's lots of advantages when it comes to low code. Of course, you can enable those so-called citizen developers. So this is basically everyone who's not a software engineer but still can develop software, and it's called a citizen developer in this case. Not sure if there's a good German word yet, but that's something in English. It saves you a lot of time, up to 90%. I guess it depends on how difficult the task is and how difficult the project is that someone wants to realize. However, it's up to 90% faster. It can help to prevent from shadow IT and doesn't extend the typically prevailing IT patchwork, right? You have a little software there and you have a little software there, and then in the end, not sure if all these things work together very well, yeah, right? You need some kind of integration layer, as Sofico again showed us, and in this case, low-code can help. And another thing which is very important, becoming more independent. I guess we've all seen this, these little software developers, or this one person doing the software because this person was doing the software since ever, and suddenly this person leaves the company or is not available anymore, and right then there's suddenly code and software that cannot be maintained anymore. So you want to become independent of those single software developers. And in the end, it hopefully saves a lot of cost, right? That's why we're doing that. Need to drink a little bit of water. So there's tons of low-code platforms out there. I bet there's 500, right? We're always trying to do a little bit of research about our competition, but it's basically impossible to get to know all of them, understand all of them in detail. However, we see some categories. So there's these huge enterprise platforms which theoretically can do everything. However, you all know how it is with software that can do everything. The details are way more important sometimes, and this is why they have some weaknesses. However, they are strong in other areas. So there's Mendix, to mention it belongs to Siemens. Of course, there's Power Apps from Microsoft, together with Power Automate maybe. And there's more. And then there's those database tools where you graphically design databases, right? Relational databases typically. You can mention Airtable, it's a US company. cTable is a German company. Pretty similar companies. There's also Budibase as an open source alternative. And there's niche platforms, right? Streamsheets from Cedalo, also member of the OI4 Alliance. There's Zapier, which is just connecting with one click, typically web and internet tools, so SaaS tools, so very niche players. And then there are those very popular flow-based tools, right? Like Node-RED, we all know Node-RED. It's also open source. It's easy to deploy. It's easy to work with. And this is why it's very, very famous. But there's other tools in this area as well. So still there's a very low adoption of low code and no code in IoT, as you can see here. So companies that using no code and low code at all, they almost not use it in IoT. So this is what this graphic is showing. This is, I think, from Computerwoche, a CISO report or something like that. And why? Because the IoT is complex, right? We all discuss, we have this here, I guess, because it's complex, we want to find ways to make it easy for the end customer to use it. And there's these physical things that you want to integrate. Not just physical things, there's also those historians, those databases that collect data, save data. But then there's this connectivity issue, right? You have tons of protocols, you have tons of ways to transport data from A to B. Then there's data processing, so the real business logic. And in the end, typically you have got user interfaces. In most cases, sometimes not. It's pure backend or pure notification-based systems. However, typically you have all of this, and this makes it very complex to do with low code, right? We are still talking about low code. And when we want to develop solutions using low code, we typically face, when I say typically, the company is 2 years old, right? But Burkhard and I, we both worked in the industry for quite some time, so we always see those repeating challenges. And we believe we found some ways how to address them, at least, tackle them. So first of all, if you go into a manufacturing plant and you say, okay, guys, let's just connect your new machine, and then we get some data out of it, and then we visualize the data and we analyze it, and maybe we use some AI. They would rather say, wait a second, you cannot touch my machine, you cannot touch my PLC, it's not going to happen. So we need to find ways how to address that issue, and we do it by basically simulating everything, first of all. So you can, with our platform, simulate the whole product, all the inputs that you want to have, right? All these physical things and all these interfaces, you just simulate them, and later you switch to the real systems, right? Making it a bit easier for production people that are a bit afraid that you touch their machines and you stop them, in worst case. So second one, legacy. We heard it yesterday from Jody from TNO. Who brought up this point. There's so much legacy out there, legacy systems, custom software, custom development, and custom legacy machines also. They need to be integrated. And we believe we found a way how to integrate those legacy systems using the one thing that they all have in common is code, right? There is software in place, and software consists of code, of functions, basically. There are functions in the code. And as you can see later in the demo, a bit hard to explain, we basically connect and integrate all these things and the legacy stuff based on the code functions. Show you later more. Third point, you typically have a strict governance and maybe some distrust of at least external cloud or cloud in general. Sovereignty, I think, is the answer here. So sovereignty about data, algorithms, the applications that you create and everything need to be in the hand of the user and then of the customer. We don't own the stuff that you build with our platform, for example. So this is just a little sneak peek to our tool. I want to use this one, it's so cool. So this is the so-called Heisenware app builder here. So on the left side, you have it looks a little bit like PowerPoint or something like that. In the middle, you build your business logic, your back end. On the right side, you build with what you see is what you get, your front end. And in the end, you just deploy and you scan the code and you have the full app on your phone or on your computer or wherever. And I'm going to show you in a second how it works. But first of all, let's talk about some, we're good in time. Let's talk about some use cases. First of all, the machine countdown. So this is a company doing metal parts and metal processing. I don't know, I think like 250 employees and 2 plants in the area of Lower Saxony. And they have those Wärmer signal lights installed on the machines, right, that you know is the red, the green, and the yellow. And on some machines, right, and it's connected to a PLC. And then they have an ERP system. It's not SAP, it's not Microsoft. ERP is some ERP, right? And they have a production order in there. And in the production order, from the production order, they know how long a specific work piece will be running in automatic mode on a specific machine. So that's the information that we want to have in order to show a countdown when this machine will be ready on a screen right in front of the machine or somewhere else, remotely on a phone or on a desktop. So we need to integrate. Now it gets a bit more complicated maybe. So we have the machine 1 with the PLC and the signal light on it. And this is from Wärmer, and it's always getting those XML files as an output. So they write all the data, when it's becoming green and red and yellow and so on, it goes all in this XML file. And we have other machines without a lamp, just a PLC, Siemens PLC. Some are OPC enabled, others not. So it's very typical, I'd say, in Germany or in Brownfield in general. And then we have the ERP here and the production order, and this is basically an SQL database. So we get all the stuff from the XML and from the PLCs and from the SQL into our app builder, and then we build this app where you can show this countdown per machine. And when I say we build this app, the customer builds the app. But honestly spoken, it's still a very new concept, so we are usually helping the customers building the first prototype, doing it maybe for the first machine, and then handing over the project to the client so they can connect their other. I think in this case it's roughly 35 machines, in one plant or in both together. I'm not sure. Another use case. This is with the Stadtwerke, utilities company, which you find in every city, and they want to install those CO2 sensors. So this is its CO2 sensor here, so it can measure the CO2 in the air. And once it's too much, right, you need to open the windows, for example, in classrooms, in schools, or in kindergarten, something like that. And the task here is to commission those sensors and give the worker, the person doing the commissioning, guidance using an app. Okay, so you need first of all to scan a code at the sensor. Then you need to scan the code in the measuring point, for example, the classroom. You somehow need to identify the classroom, right, where the sensor is installed. And then you want to manage the sensor over its whole life cycle. Maybe at some point in the classroom, one sensor will change, right, because this one is broken, you need another one, but the measuring point stays the same. And this should be all then managed. And all the metadata recorded over the life cycle. The client in this case calls it the digital twin. Not sure how much this is that fits the digital twin general definition here. However, the client calls it like this, and this is how it looks like. So the final app, which was built or is built with the Heisenware app builder, in the first place scans the sensor and scans the measuring point, a classroom, for example, or you have a manual entry. So you somehow need to identify the room and the sensor, and you connect them. And these sensors, they send via LoRaWAN. Of course, there's gateways in between. And then there is a LoRaWAN server, which is taking the LoRaWAN signals in this city. And then it's connected to the Heisenware cloud again, or the Heisenware backend, basically. It doesn't need to be necessarily a cloud. This is why I'm saying it. And via REST for some data, and MQTT for the actual time series data. And then what we do is basically save all the stuff in a PostgreSQL database, which you can also set up using low code or without coding, basically, in our tool. So that's more or less the use case here that we realized with the Stadtwerke. I'm not sure if I can mention the city, but maybe you've seen the logo on the first slide. So okay, let's. Yeah, we've got 10 minutes left. Maybe I can do a quick live demo. So the idea is to give you a little demo. What do I need to do here? Yes? There you go. So this is I'm not sure if I'm still logged in. No, I'm not. Give me a second. I need to log in. So okay. Yeah, I saved my stuff here. Okay, good. So what you see is now the app builder. So it's really there. So and the idea is now to connect this is a gyroscope sensor here on a little microcontroller, an Arduino in this case. This is a power supply for the Arduino. It has Wi-Fi. It's connected to the hotspot of my phone. This is why we have all the stuff here. And then we have this little LED lamp here. It's connected to Burkhardt's computer. So it's also in the internet, but in two different networks. And the idea is now to control the light using the sensor. Depending on the angle, we want to have different colors. That's the use case. And at the same time, we want to build an app which also visualizes the angle of the sensor. But this is not my computer, so and I'm very nervous, but I will try it. And I will just click a little bit around, and I'm not a software developer. However, setting up a basic, and we will develop for the phone, as you can see probably. So this is what I'm doing now is I set up 2 pages with the navigation. So maybe you can see at the bottom here, we have now already a navigation between the 2 pages. Of course, I prepared a little logo, which we put here. We could add icons and text and whatever, but it's pretty boring because it's static. More interesting is actually the real data. So I said in the beginning, okay, no, I skipped the simulating part that I mentioned because of the time. And I will just get, here I have all my connectivity stuff. I can connect to, as you've seen, to SQL, to XML, to OPC UA, to S7, whatever. But here I have the function which is written on this Arduino here. The pitch is this one. So this is, as I said, we can remotely call the functions, in this case C++ functions, written in C++ from the Arduino, and trigger them here, and you get an anchor, right? Depending on what I do here. Yeah? Maybe, hopefully, yeah, you can see it. And now maybe you've seen when I go up, it says minus, so I can modify the data here in with JSONata or with some basic Java. It's low code, right? It's not no code, so you can do a little bit more here. And then I get the 77, basically, when I do x times -1. So, and now I said I want to visualize this. So I take a circular gauge here, for example, as a visualization, and I go, for example, yeah, I could configure it even more here in all the colors and in your company colors, whatever you need. And now I connect, so I've built the front end, right? And I've built the back end. And now I connect the two. And if I don't want to click here all the time on the manual trigger, so I say, please read please trigger this function every second, for example. I can do it faster, I can do it slower, depending on the use case. And I have a test mode here. And with some luck, you can already see that the sensor is now connected to the internet. And the data is in the app, right? So this is working pretty well. But now we said we want to control the light here, depending on the angle of the sensor. So, Burkhard, I think it's offline. I think it's off. So it's gray here. This is
also nice to see if something is offline. So,
yeah, this case is offline. But I can show you in the meantime maybe some icons. We could use then some icons here, right? This one, for example, put it here because it's the.
there you go.
Okay, there you go. Burkhard started the.
My laptop started sleeping and the
Yeah. So we have the LED lamp, which is connected to Burkhard's laptop here. It went into sleep mode, but now it's awake again. I hope you are also still awake. So let's see if it works. There is a police function on it. In this case, it's written in Node.js, I think. So we have a Node.js connector in this case. And if I trigger this police function, you see it's in police mode now. And there is a connection. There's an off function, so I can turn it off. But now I don't want to turn it off and on from the app builder here. I want to do it from the final app. So what I do now is I put another modifier here, and this is a little bit more complicated, and I hope I can remember it. So whenever this angle is bigger than 60 degrees, and now I need to hurry up. I've got 5 minutes. Or it's below -60. Yeah, this is again a JavaScript expression that I use here. Then it should turn red, for example. And if not, it should. No, I need this one here. And otherwise, it should turn green. See, I triggered. It's on 40, so it's green. Yeah, it's in the green zone. And now I have a function here which is set color. Also, again, Node.js code on. It's a connector basically here, or it's a code it's controlling the lamp. And this again has an input. I could say red, yeah, and it turns red. However, I don't want to put it here. I want to have an automatic input. So I take this one here as the output from the pitch to the input from the set color. And then I do another thing. I also put it on a trigger, which means whenever it's changing, trigger the function. So it's also changing the color. And with some luck, going into test mode now, See, it's above 60, so it's red. In the green zone, it's green, and below minus 60, it's red. So I've basically connected two physical things in 5 minutes live on stage, and at the same time visualizing the stuff. And last but not least, let's hope it also works. I'm going to deploy the whole thing. So what's happening now for the technicians? There's Docker containers built in this second, basically, so that you can use then this app later wherever you want to use it. But it takes a second because there's a whole building process in the background going on. And if this is not going to work, then please excuse me. I don't know. Yeah. But, okay. Let's say 99% worked. It's a bit too slow. It shouldn't go this long. Maybe I can refresh. Does it make sense? I'm not sure. Yeah. Yeah. So now that it's a bit not a good end. Okay, there was something deployed. What I forgot is at the same time you can build, of course, for desktop, right? So that's not a good scale. You can build for desktop. It looks a bit different. You need to make it look nicely here. You can build for so it's progressive web apps. You can build for phone, for everything at the same time. And let's try one. So it says V2 here. So there was something deployed, but maybe it's because of the internet connection. But you see the app. You see the app is working. So it was deployed. There you go. So you could scan it now with your phones, but as we don't have too much time, let's skip this. It's password protected. I need to make it public. Password is better, but now we want to quickly show it. So there you go. Hopefully, this is the live app, visualizing the sensor and also controlling the lamp here based on the angle. Yeah. And yeah, that's it. Thank you very much.